買平幾嚿已經
以前係基本上真係平咗，
都好平，4000蚊出到，大嗰啲大。
So back to our questions. Anyone know why there are zeros in here? Okay, anyone from accounting, maybe you can explain to the class.
You can speak English.
都可以。
就是我现在知道的一个就是，我先说 tax 这个地方，就是 tax 这个地方呢，它是空了2格，然后让你看看前面的几个 tax 是什么，然后第二行 tax 就是多了1格，然后让你看前4个 tax 是什么，然后后面一行的话是让你看整个的 tax 是什么，然后看前面的，然后让你去预测下一个 next token 是什么。
对对对。So let me repeat in English. So he's saying because of text is auto-generated and it should not have the ability to view the text which have not been said. But for image is a different scenario. So for image, when you see the image, you see the whole image, right? You do not generate the image pass by pass. So you can see the whole image. So image can attend with itself, and also image and text should attend. So this here control the relationship between text and the image, and here control the output text, which do the auto generations. This part is just doing the exact same thing, so it is not necessary to have this part. So exactly same thing as this part, right? So because this one already cross attend with the image, so you do not need a cross attend in here. And this part, because of text auto-generated thing, auto-generated text, this can also be 0. Okay, so in lab 3, we have discussed the architecture almost. The auto-generative decoding, so starting off with the beginning of sentence token and predicts ends when it sees the end of sentence tokens or the max step. And in training, we will train all the parameters of the encoder and decoders. So the image patch of GitV base, which trained on this data set, the image patch encoder is actually 16 by 16. And also it used a text generator which is very similar to the GPT-2. Note that the Git base uses the sequence-to-sequence cross-attention generator. Okay, so here is the dataset. It got 1.1 million questions in lab 3. And it kind of got some question like, is this indoor? And some other numbering question like, how many people are there and what color is there. And there is another code for you to try to run at home, which is just to simply run the Git-based model. So the code will allow you to run two models. One of it is the Git-based model. So when you try to run this code, it will load the Git-based model and do an inference. So you can kind of have a feel of what the Git-based will provide, will generate, what text will be generated by the Git-based. So let me go back to the So when you run the code examples in the week 4, it will read the sample image that you have just downloaded. So the sample image, if you run the O1 code, it will download an image into the server, and the Git-based will read this image. And after reading this image, it will say something like, it will ask a question, what is in this image? And the answer will be cat. Okay, so this is just simply how to run the Git-based in the server. So if we look into the code, it's very similar. So model loading, asking questions, and then print out the questions. And you can try different types of questions, like what is in this image, how many colors, how many items, and so on and so on. So when I ask what is in this image, say the expected output is a cat sitting on a laptop, what color is the object, orange and white, how many items are there too, is this indoors or outdoors? Indoors. Okay. So these are the expected output of the Git-based model. So Git-based cannot do well, it cannot do complex reasoning. It is weak at reading text and in images, see detailed scene and descriptions, multi-step questionings. And perhaps we might be able to fix it with fine-tuning, but we will see. You need to try out whether it can perform complex reasoning or how complex you can get it to work on, or can you fine-tune it to read text? We will see with the lab 3 in your project. Okay, so fine-tuning, as usual, we will be using LoRa. So LoRa will be adding and adapting weights in the attention matrices, or QK, Q or V. So slightly different for vision language model, because you have vision and text. So you can apply LoRa in both vision and text attention. Okay, but actually you have a choice. You can only fine-tune the language model. So this is the cheapest options. if you choose option 1 in your project, you need to specify why, the reason why you only need to fine-tune the language decoder only. And there is option 2, which you can fine-tune both the vision and the language part. It will be more expensive, but better for domain-specific images. In Lab 3, I actually fine-tuned the model using radiologist medical data set. So also a very important thing when you are fine-tuning, you need to set the hyperparameters, and you can test out different hyperparameters and what are the good hyperparameters. So in Lab 3, I kind of already showed you some hints of what hyperparameter to choose from. Okay, so let us have a brief look into what the expected results when you run Lab 3. So after running Lab 3, you should have different folders containing different hyperparameters of different training. So for fine-tuning, what are the hyperparameters that you can choose from? You give me some name of what the hyperparameters that you can choose for fine-tuning. Okay, for fine-tuning, you can pick the R, which is the number of dimension. So the rank. Remember the rank? Remember what is the rank? Remember what is R? Okay. Rank. Okay, so I've heard someone ask what is R. Okay, so let me repeat it once more. So R is the okay, I need to go back to week 3. So R is the, you can thought of this, the matrix size. So the higher the R, you can have the larger the matrix size for the adapter weights. Okay, so let me go back to the matrix multiplication. Okay. So okay, maybe I will use another matrix. Oh. So when you're doing matrix multiplication, assuming this is the weight that you need to update, so how to reduce the number of operations to create a 4x4 matrix? In the last lesson, we have been taught you can just use this one, right? You can reduce the columns in the first matrix, which will still create a 4x4 matrices, correct? So the R refers to the dimension of this part and this part. Okay, ring any bells? No? Okay. So R is the matrix size that you are going to do fine-tuning, the size of the adapter model. The LoRa alpha is how much you should update. So how much you should be, like, if you have a very good data set, you want to update the model as much as possible. So LoRa alpha refers to the strength of the update. Recall any? Okay. I see some of you are very confused. Maybe I need to go back to the week 3, but I think I will continue here for now. So LoRa dropout and causal ML. Okay, these are the hyperparameters that you need to be fine-tuning. And this learning rate refers to the learning rate when you fine-tune the results. So after running the lab 3, you should have all the comparison against each hyperparameters. Okay, so in the demo, I used a medical data set. So it's essentially, let me check. Okay, so let me quickly finish this. So LoRa, you have the LoRa and you apply LoRa to the model and get the LoRa configurations, and you load the data set. Okay. So these are the common data set that you can get. So I picked this one, medical radiology. It's called a VQA red. When you type VQA red, hugging face, so you can see you can get some medical images. So these are some vision and query. So it have the data set contain an image, also contain a questions like what region of the brains are infracted, and the answer is yes. And it says are region of the brain infracted, it said yes, like are lungs normally disappearing, appearing, are the lungs normal appearing, it said no, and it got all the medical all the medical data set. What do you think the Git base will perform in this data set? Do you think it should be good or not? So the Git base data set is actually trained using the this data set. So this data set VQA V2, VQA V2, VQA V2. So they are the Git base is trained on this data set. What are the differences between the two? So the kit base is trained on this data set, and the task of lab 3 is trying to fine-tune a model so that it can somehow learn new sets of skills, which in here, in lab 3, I picked the radiologist data set. So if the actual main differences is that this thing is colored and this thing is not colored, and you have to think about what are the consequences of doing inferences between the two data sets. So here are some. If you run the lab 3 successfully, you will see question like which hemisphere is the Alzheimer's located, and the ground truth is coming from the data set. It's called right hemisphere. The base model will set top right or something like this. The baseline, which compare against all other methods. So we will using learning rate -5, rank 16. It will kind of got the first word correct, but it's kind of keep outputting the text because it is not outputting the end of sentence token. But at least it got the first word right. And the conservative one still does not work quite well. The aggressive one kind of got the first word correct, and the smaller one also got the right first word correct. Okay, so this is one example. Let's see another one. So after running the third lab, you can see there are sets of results that you can compare. The target of the lab 3 is not to make a model that is capable of learning the whole medical data set, but it is important that you compare and spot out what are the errors and what steps you can improve on. Okay. Because of the server computation power, sometimes you might not get good results after fine-tuning. So the learning rate I suggest is to first start off with 1 to the 0.0005. 0.0005, yeah. Okay. Oh, please, okay. Okay. Okay, so for the alternative data set, you can use the other 4. Document analysis, scene data set, or pathology. Actually, I think this one might be a better fit for lab 3 because it's also reading the color images. So any questions? No questions, so all understand what I've said? Okay. So because I often ask, is there any questions? And there are often no questions. So I have some questions for you. Because I have no idea of what you understand or not. So in order to have a for me to have a better view of what is being taught and what is not. So I have prepared some questions for you. So you do not, it's not actually graded. I just need to understand what your strength and what you actually understand. Okay. So there is a review quiz for week 1 to 3. So it only contained 20 questions because you have no questions for me. So I have 20 questions for you. If there are questions, I will answer questions right here. So this is just a quick reminder of week 1 HPC fundamentals. I know some of you will use AI to answer, so I've tried AI, and I've also inserted a trick options for AI. So please try it. If you fail for that questions, I will know that you are using AI. So I will do it this way, and you can use AI if you really want to, but I just want you to have a kind of quick understanding of what has been taught in this course.
有試新嘢呢度。我想問啲智力級。但我亂撞嘅啫喎，根本唔係。
其實可能認真打工。
So I presume the limit of the quiz is 1 hour. I presume you can finish in I think half an hour to 20 minutes, or 20 minutes to half an hour. Only 20 questions. And I will go through the questions. So let me see what AI tells me. I think it's okay to use AI, but after it gives you, you need to think about whether the answer is actually correct or not. So it's okay to use AI as long as you kind of think about it.